This learning object is a production of Abu Dhabi Men's College, Center of Excellence for ICT and Learning Technology.
In this training module, we're going to talk about this flight simulator, which is a Hawk 54 simulator brought here from the RAF in the UK. What we're going to talk specifically about are 5 instruments. They are the airspeed indicator, the artificial horizon, the compass, the altimeter, and the vertical speed indicator. It's important for our students to learn how these instruments operate and to understand how a pilot uses these instruments in order to rectify problems as they arise in the field. The first instrument that I'll discuss is the IAS. IAS stands for Indicated Airspeed. This works much like the speedometer in your car. It gives the pilot a reference as to how fast the aircraft is moving. Speed is very important in aircraft design, as commercial aircraft are designed to fly below the speed of sound, and military fighters, much like this one, are designed to fly well in excess of the speed of sound. The military fighters differ also in the fact that their performance improves at high speeds. The second instrument that I'll discuss is the artificial horizon. You'll notice in the artificial horizon gauge, in the center of the gauge, there is 2 red bars and a red dot. This represents the aircraft. In the top part of the gauge, it's blue, and in the bottom part of the gauge, there's a dark color, a brown or black. As the aircraft moves up, you will notice that the indicator of the aircraft moves up into the blue. And if I push the stick forward to move down, the nose of the aircraft comes down into the dark section of the gauge. This gives the pilot a reference as to where the aircraft is in position in the sky. Is he climbing or is he descending? Next, if the pilot turns to the left, you will notice if you look at the artificial horizon gauge and you look at the horizon out around us that they match in relation to what the aircraft is doing. So if the aircraft is turning left, then the left wing goes down and the right wing comes up. And if it comes back over to level and you turn to the right, the same thing happens only on the right side this time. The right wing goes down, the left wing comes up, and I can see by the gauge indication and the panoramic view that I have that they match, that they are similar what the aircraft is doing. So it is a true indication of position of the aircraft in the sky. The third indicator that we're talking about is a compass. The compass works much like any standard compass. It gives me direction. It's a reference as to which way am I traveling in this aircraft. So if I was a pilot and I'm looking for an airport and I know that the airport is in the west, then what I would do is I would turn the aircraft to make the compass rotate so that I can fly towards the W on the indicator. Once that W lines up with the nose of the aircraft, I fly straight and true, and I know that I'm on track to hit that airport. So the compass is basically just a direction indicator. The next indicator that I'm going to discuss is the altimeter. The altimeter tells me how high I am above the ground. Now this is obviously very important because the pilot needs to know when he's approaching an airport how high he is, and he needs to know when to start to descend the plane as he's approaching. So you'll notice, again, using the altimeter in conjunction with the artificial horizon. If the pilot pulls back on the stick, the aircraft on the artificial horizon gauge, the nose of the airplane starts to go into the blue, and I also notice that the altimeter starts to count up, indicating that the aircraft is climbing. If I push the stick forward and the nose of the aircraft comes down, shown by the artificial horizon, then I see the aircraft moves into the brown section, and I see, again, the altimeter starts to show that my altitude is decreasing. The next instrument and last instrument we'll discuss in this module is going to be the VSI, which is Vertical Speed Indicator. This works in conjunction with the artificial horizon and with the altimeter. So if I bring the aircraft into straight and level flight, and then I pull gently back on the stick, the artificial horizon indicator shows the airplane moving into the blue part of the indicator. I see the altimeter starts to show I'm climbing, and the vertical speed indicator tells me how fast am I climbing, how many feet per second or per minute that I'm climbing. The opposite is true if the pilot pushes forward on the stick. You will notice that the artificial horizon shows the aircraft moving downward into the dark position of the indicator. The altimeter starts to count back in the opposite direction, indicating I'm losing altitude, and the vertical speed indicator, the needle arrow on there, also changed positions and started to indicate that I'm climbing downward. And now it is telling me the rate of climb that I am actually descending the aircraft at. So as we can see, all of these gauges are important to the pilot because he needs to know how fast he is going, he needs to know the position of the aircraft in reference to the ground, he needs to know what direction he is traveling, he needs to know what altitude he is at, and he needs to know how fast he is climbing or descending in the aircraft. And this is how air traffic controllers also can keep aircraft separated by knowing this information and to help prevent air accidents.